Hi, and welcome to BJC Mathematics. Our topic for today is algebra, and I love algebra. We will be simplifying expressions. Our learning objectives. By the end of this lesson, you will be able to, drum roll, simplify algebraic expressions by collecting like terms. Now, there are some vocabulary words that you are going to be hearing a whole lot of during this lesson. The first one is variables, and it's a big deal because to me, this is the reason why we actually use a whole lot of algebra. We have unknown values and we need a way to represent them. We use variables. They are usually denoted by letters or symbols. So for example, you would see something like this: 2x plus 3p minus 10y. The variables in this would be x, p, and y. The second is constant. Now you might already be familiar with this word because it means unchanging when something is constant. In algebra, a constant is a value that does not change. Or simply, a number all by its lonesome self. We have y equals 2x plus 6. The 6 is the constant. If you notice, there is another number here. The number is 2. However, the 2 is not by itself. It is attached to the x, and it is attached by multiplication. The 6, however, is by itself, so we call it a constant. Now, we have another example on the screen. The 1 is all by itself, a number all by itself. This is a constant. However, the 4, 2, and 3 are all coefficients. They are multiplying the variables. Now, let's think about this, because sometimes we use a whole lot of big words and things can seem more complicated than they really are. On the screen, we have A. How many? 1. Just 1 A. So when we only have 1, we don't write the 1 if we only have one variable. It's just 1A. When you see this, I want you to think 1 apple. For this lesson, I can almost guarantee you that this will help. So 1A, think 1 apple. Just using something to represent. 3A, the 3 is a coefficient. So it's telling us how many A's we have. 3 apples. B. When we don't see a coefficient, we know that it is 1. So we have 1B. I am thinking, in my mind, 1 banana. 2B. The coefficient is 2. And in my mind, I am thinking 2 bananas. This, I promise, will make it tons easier. Another terminology you will be hearing will be algebraic expression. An expression is a mathematical phrase combining numbers and or variables using operations. So let's see, it could be a number by itself, it could be a variable by itself, or it could be a combination of numbers and variables. What is important is that it cannot have an equal sign. Now, this here is an algebraic expression, 7n plus 2. We have the 7, which is a number, but it is multiplying. It is attached by multiplication to a variable. So the coefficient is 7, the variable is n, the constant, the number all by itself, is 2. The operation is addition. For this lesson, we will be using two operations, addition and subtraction. And then we have terms. 7n is the first term in this expression, and 2 is the second term. Simplify the following algebraic expression. This would be a typical paper 1 BJC question. 3a plus 4b plus 1a plus 2b. Now, ideally, this is how you would think about it. These are all steps. They're telling you what to do. We have 3a, and in your mind, you can go ahead and think 3 apples. Plus 4b. So I have added 4 bananas. Plus 1a. So I just went ahead, I added another apple. And then we added 2b. Do you see the correlation? 3a plus 4b plus a plus 2b. What would the final answer be? Wow. Right here, I hope you have something in your mind before I go ahead, because we're going to walk through that again a little later. But first, algebraic terms. So right here, again, it can be a variable, it can be a constant, or it could be a combination of both. This would be algebraic terms. I know the definition sounds similar to expressions, but as we go through the lesson, you will be able to see the difference. So we're back here. This time, we are going to solve the question, but we're going to do it by collecting like terms. And we'll see if that answer you had in mind earlier was correct. The first thing I did was I separated this expression into terms. And when I separate it, I include the operation that's in front of it, because the operation is telling us what to do. This expression has 4 terms, 3a, 4b, a, and 2b. Again, please notice that I include the operation along with the term. 3a and a are like terms. The variable is exactly the same. A and A, apples and apples, bananas and bananas. 4b and 2b are like terms. Why? Because the variable is exactly the same. We put bananas with bananas. Now, because we know that you don't have time to draw out all of these things, algebra has come to make your life simpler. So what we do is we rearrange or we collect like terms together. 3a plus a plus 4b plus 2b. Our final answer, 4a plus 6b. This is our final answer. At this point, we cannot simplify it any further because a and b would be unlike terms. Let's have a closer look at this so that we can have smooth sailing. Important. Terms which use different powers are not like terms. What does this mean? Example, z and z squared are not like terms. They cannot be collected together. Notice the difference of just that little number. That exponent made a world of difference. Let's see. 4a plus 4b, like or unlike? Unlike. Apples and bananas. Like or unlike? 4y plus 1y. Like. And we can simplify that. 4y plus 1y equals 5y. I hope this is feeling extremely easy for you. Like or unlike? 4 plus 3. If you said like, you are absolutely correct. And what is the special name for numbers by themselves? Do you remember? It is constants. So 4 plus 3 equals 7. And then we have 4a squared plus 3a cubed. I must have been really excited at this point because I put the answer in already. These would be unlike. Why? The exponent on the first term is 2. The exponent on the second term is 3. So these would be unlike. Don't worry, you won't be seeing a lot of that. A good example, number 1. So we're going to walk through a couple of examples and then we're going to do some practice questions. For the examples, I am going to move through, but when I reach the practice, I'm going to try to give you a little bit of time so that you can get a head start on me. All right, so our first example, our first official example, yay! 2x plus 4y plus y plus 3x. First off, we look at our terms. We have 4 terms. And at this point, we want to try to identify our like terms. So we have 2x, take away x. Notice that I brought the operation that was in front of that 1x. So 2x, take away 1x, plus 4y plus 3y. This is where we are collecting our like terms. Final answer, 2x, take away 1x, is x, and 4y plus 3y is 7y. Please make sure that you still have that operation in the middle. Final answer, x plus 7y. And don't forget, have paper and pen or paper and pencil, take down these examples. Example number 2. We have 2y squared plus 9 minus 2d plus 4y squared. Now, step 1, let's look at our terms. We have 4 terms. Let's see which are like terms. All right, we have y squared. So 2y squared plus 4y squared. Then we have the constant that's all by itself plus 9. And then we have a third term, which is d minus 2d. We collect our like terms and now we simplify. 2y squared plus 4y squared is 6y squared. Now, you may have noticed that I switched the last two terms around, and that is because in algebra, we usually put the constant at the end. So our final answer, 6y squared minus 2d, because we're keeping that operation in front of the 2d, plus 9. This is our final answer. We cannot simplify it any further. Example number 3. 6v minus 2c plus 4v plus 6c. Let's look at our terms. How many terms do you see? If you said 4, you are absolutely correct. Now, let's collect like terms together. 6v plus 4v minus 2c plus 6c. Remember, keep your eyes on those operations in front of each term. Now, 6v plus 4v, and I would read that second portion as negative 2c plus 6c. 6v plus 4v is 10v. Negative 2c plus 6c, 4c. I know integers is not usually a favorite topic for many students, but if you owe the bank $2, that's negative 2. When you put $6 on that account, they're going to take that $2 off first, and you will be left with 4. So final answer, 10v plus 4c. Now let's practice. And we're going to begin with something really simple. 4a plus 3a minus a. And remember, when you don't see a number on a variable, what is the coefficient? If you said 1, you are absolutely correct. Give yourself a pat on the back. 4a plus 3a minus a. The answer is 6a. Practice question number 2. And I threw this one in because I feel sometimes we let these things scare us. And if that happens, if you're feeling a little intimidated, say it aloud. It might help to make more sense. 4ac plus 5ac. If you notice, the variables are exactly the same. 4ac plus 5ac is equal to 9ac. Piece of cake. Now, let's get into collecting those like terms. I want you to think about the steps that we went through. Our question, 8c plus 2p minus 2c plus 4p. Consider, how many terms do you have? Circle the terms. Then you're going to collect the terms and simplify. Take it one step at a time. So, We have 4 terms, 8c, 2p, we have 2c and 4p, but we have to keep the operations in front of those terms. So now when we collect them on the second line, we have 8c minus 2c plus 2p plus 4p. When we simplify, 8 carrots take away 2 carrots, 6 carrots. Yes, although you might be reading one thing on the screen, in my mind, this is what I am thinking. And 2 pens plus 4 pens would be 6 pens. Number 4. Going to give you a couple of seconds. Write the question down. Identify your terms. So circle those terms. How many terms do you see? Did you make a special note of those operations? Now, collect your like terms together. Giving you about 5 more seconds. All right, let's do this. Let's see how far you got. Did you see that there were 4 terms? If you did that, yes. Now, that was step 1. Step 2, did you collect those 8 terms together? So you have 6a minus 2a. If you did that, step 3, did you see those w terms? So plus 5w plus w. If you did that, final step, we simplified. 6 apples, take away 2 apples, 4 apples, 5 watermelons plus 1 watermelon, 6 watermelons. Yes, I do love fruit. All righty. Now, practice question number 5. 8a plus 3c plus 6 minus 5c plus 3. All right, take a deep breath in. Let's do this. How many terms do you see? Circle them. And I hope you're still writing down your questions. Mom and Dad, go ahead, feel free. If you didn't like it before, now is a great time to get your algebra practice on. So you're identifying. How many terms do you see? If you said 5, you are well on your way. Circle your terms, and then you're going to go to your second line and you're going to collect them together. After you've collected them together, you're going to simplify. I'm going to give you 5 more seconds. 4 more seconds. 3 more seconds. 2 more seconds. And that was your final second on this question. All right. Now this question did change slightly, so please do forgive me. Let me go back to this question. If you worked this question out, you should have had 8a, and I'm going to put this in here. So let's do this. You should have had 8a, and there was only one a term in this particular question. Plus, you would have had 3c, take away 5c. Those would be our c terms. And then we would have had 2 constants in there. So let's take it just one step further back here, because these would have been our terms, and this would have been the first step that I recommended, that you identify all those terms. It's going to overlap a little bit. Work with me. There we go. All righty. So we would have had 5 terms. In our previous questions, we would have had only 4 terms. So we had 5 terms because I didn't want you to get used to just seeing the same thing all the time. So we have 5 terms. We have 1A term, that was the 8A, plus 3C. And then we had the plus 3C plus 6 minus 5C plus 3. Now, let's resume. So we're going to collect. We have 8A and only 1A term. And then we have plus 3C. And then we look to see, do we have another C term? Yes. Even though I might have mutilated it with my circle, minus 5C, because I'm keeping the operation in front of the term. The operation is telling me what to do. So gotta have those instructions. Then we have the constant, that's plus 6, and then we have plus 3. All right. Now, from here, now that we collected them, let's simplify. The 8A is all by itself. So 8A. 3C though, that plus 3C minus 5C. So you have $3 on your bank account, but there's a service charge for $5. I'm going to say that again. You have that plus or positive 3C, take away 5C. So we're looking at the question 3, take away 5. You have $3 on your bank account, but they had to charge you $5 for something. 3, take away 5. What will your new balance be? Well, you had 3, so they're going to take that 3, but you're still going to owe $5. We are going to use our negative sign for that. So negative 2C or minus 2C, that's how we will read it when we are answering our question. The final part is 6 plus 3, and that's going to give us 9. So the final answer for this question, 8A minus 2C plus 9. We cannot simplify that any further because A, the C, and the constant, they are 3 different terms. All right, now let's move to the final practice question of this type. So this is paper 1 style BJC questions. And I'm just going to quickly remove all of the annotations that I made a couple of seconds ago on the previous screen. All right. So in this question, which was the revised number 5, if you will notice, there are no A terms in this one. So what I did was I collected all of my constants together, the 8 plus 6 plus 3, and then I did plus 3C minus 5C. And the final answer is equal to 17 because 8 plus 6 is 14. 14 plus 3 is 17. And this positive 3C minus 5C, negative 2C. This is our final answer for this expression. Now, I think you should have a good idea of how to do paper 1 style simplifying expressions like this. Let's have a look at paper 2 style questions. So for paper 2 style questions, we're gonna see a whole lot more word problem style. This necklace is made from two kinds of beads. The round beads cost $8 each, and the hexagonal beads cost $B each. So if you're writing this down, please put in the word each. The round beads cost $8 each, and the hexagonal beads cost $B each. Write an expression to represent the total cost of this necklace. So when we are writing this expression, we are also going to be simplifying this expression. Now, I want you to have a look. And sometimes when I'm in class, I would tell my students, we tend to overthink math sometimes. So you want to think, I'm in grade 1, I'm in kindergarten. So you're just looking at it. If each round bead is A, how many A's would that be? If each hexagonal bead is B, how many B's would that be? All right, let's break it down. So what we're going to do here, we have 4A representing the 4 beads on the left, and we have 4A again on the right-hand side because we have 4 beads on the right-hand side. And then in the middle, we have 3B representing our 3 hexagonal beads. So our expression 4A plus 3B plus 4A. And then I went ahead and simplified. That will give us a grand total of 8A plus 3B. All right, here is another question. Write and simplify an algebraic expression to represent the perimeter of the triangle below. So a triangle has 3 sides, and perimeter is the distance around the triangle. We're going to be adding the 3 sides. This is where it gets exciting. Let's do this. Our solution. Our first side, which I have highlighted in pink, is 4y. So we put down the 4y plus, we have a side here highlighted in yellow. That's y plus 3. And then our third side, which is highlighted in blue, 6 minus 2y. So I want you to get a feel for how easy it is. If you know how to find the perimeter, and we give points. So we're going to be giving you points for pretty much almost every step, especially when we have these questions that are worth all these points. So if you notice, a lot of the questions, especially on paper 2 BJC, will be worth 2 and 3 points, sometimes 4 points. So you want to make sure you include these steps and you celebrate every single step that you understand and you get correct. So I have 3 sides. I have 4y. Then I have plus 2 plus y plus 3 plus 6 minus 2y. Now, let's go back to what we learned in this lesson. We're going to be collecting like terms. The first term is 4y. So we put down 4y. Then we have plus y. Of course, I know that some of you have already gone ahead and started circling items just to make sure you are on track with how we were doing this. So I'm going to go ahead and do that as well. That circle there, we're gonna fix that circle. Let me just erase that circle. We're gonna do that circle a little bit better. So right here, because I want to make sure we get that plus sign in there, and then here, good. And we have, how many terms do we see inside this expression? And we know it's an expression because it does not have an equal sign. So we have 5 terms. All right, now let's resume where we were. So we have our 4y plus y minus 2y. Then we have plus 3 plus 6. Our final answer, 4y plus y is 5y, and 5y take away 2y, 3y. Finally, 3 plus 6 is equal to 9. So our final answer is 3y plus 9. Giving you a couple more seconds to take down this example. So, how well can you simplify algebraic expressions by collecting like terms? And I'm just going to move these annotations that I had on the screen. There we go. So, I don't even know what like terms look like. I'm totally lost. Is that you? Or the second one? I can collect like terms and simplify. Just no negative numbers, please. If everything is just going to be positive, I can handle it. Is that you? If so, that is good. And third, I fully understand. Thank you so much for joining me today, and I look forward to seeing you next time. Have a good day.